Hi everybody, in this video I'm going to introduce some terminology related to hypothesis testing for one sample. And this kind of foundation you'll end up using in other hypothesis testing examples that we'll do later on in the summer semester. So we're going to focus today on section 7.1. We're going to introduce the idea of hypothesis testing, and then next class we'll talk about how to hypothesis test for a population mean. And then in a later video we'll talk about how to hypothesis test when you have a proportion. Okay. A hypothesis test is a process that uses sample statistics to test a claim about the value of a population parameter. So it kind of along the lines of earlier when we've talked about senior citizens. Okay, I always use that example of we want to know on average how many bowls of bran seniors eat a week. Okay, we can't ask everybody, but let's say hypothetically we think that on average senior citizens in general eat 3 bowls of bran a week. Okay, we might want to test to see if that fact is actually true. So we would actually gather some sample statistics from a group of senior citizens and basically use that to figure out, is this claim about 3 bowls a week on average actually realistic, or is it totally wrong? Okay. Here's another example. An automobile manufacturer advertises that its new hybrid car has a mean mileage of 50 miles per gallon. To test this claim, we'd have to just get a sample of these automobiles. And if the sample mean differs enough from the advertised mean, you can end up saying that that claim in the advertisement is wrong. So a hypothesis that you make in statistics is basically just a claim or a statement about a population parameter. And that might be either a population mean, which is mu with the little u with the tail on it, or it could be a population proportion, which we'll talk later. When you make hypothesis statements, there's always going to be two statements that you make. One is going to represent the claim in the problem that's given to you, and the other is going to represent the opposite of that statement, which is called its complement. And basically, when you find out that when one of those hypotheses is false, that must mean that the other is true. Okay. So one of these statements is called the null hypothesis. And the one thing you can always tell if you're trying to distinguish a null hypothesis from the alternative, which I'll show later, basically your null hypothesis will always be either less than and equals the equal sign, or greater than or equals. So the null hypothesis always has an equal sign in it. If you don't see an equal sign, it can't be the null hypothesis. No, always, 100%. We sometimes denote the null hypothesis as HO. Some people refer to it as H naught, H sub 0. You might even hear me call it the HO. Okay, and one of the things that you'll commonly hear me say in class later on is we want to get rid of that HO. Okay, and basically it's the idea that generally when you're doing research, you want to disprove your null hypothesis. The alternative hypothesis, on the other hand, never has an equal sign. So it'll always be either greater than, less than, or not equals. So if you're trying to figure out which is which, okay, your alternative hypothesis never has the equal sign in it. So that means that your alternative must be true if you find out that the HO is false. And we call the alternative HA in statistics. So when you write your hypothesis statements, you're going to always write the null and the alternative, the HO and the HA. And basically, what helps is first take the claim in the problem and translate it into a mathematical statement. Once you've derived that claim mathematically, then you would write its complement statement. So here's some examples. Okay, here HO, mu is less than or equal to some value, and the HA statement, the population mean is greater than some value. Or it could be that HO is greater than and equals and HA is less than. Or it could be an equals not equals situation. But basically, you can see that, whatever the one statement is, like if HO is less than or equals, then HA's got to be the opposite of that. Well, what's the opposite of less than? Greater than, right? What's the opposite of less than? Greater than. What's the opposite of equals? Not equals. That's not so hard. As long as you know what the claim is and you know how to, mathematically make the equivalent of it, the rest is easy. And again, your HO statement is always going to have the equal sign somewhere in it. So let's try and set up this claim. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. So the claim here, they're saying that the proportion of students in at least one curricular activity is 61%. Okay, so the big thing here is that term is, right? Is 61%, is means equals. So basically, we are given our HO statement, the HO, because HO always has the equal sign. So as a hypothesis statement for HO, we would say P equals 0.61. And the P stands for the proportion. Well, now that we know the claim, then the HA statement must be the opposite of equals. So the opposite of equals is simply not equals. And that's the complement. So basically, we would later do a hypothesis test to figure out if our claim, the proportion being 0.61, is actually the case or not. A car dealership announces that the mean time for an oil change is less than 15 minutes. So they're telling you right here, okay, less than 15 minutes. So we're saying that the mean time is less than 15 minutes. That statement does not have the equal sign in it. So that's going to be our HA statement. So the mean, or the population mean, is that U, or mu, with the the little tail on it, right, is less than 15 minutes. So that's the claim that they've given us. So HO is the opposite. Well, the opposite of less than is greater than, and the equal sign, because HO always has equals in it. A company advertises that the mean life of its furnaces is more than 18 years. Okay, so more than is the same as greater than. Okay, so again, that doesn't have the equals notation anywhere in that sentence. So there's our HA again. Okay, mu will represent the population mean, and then the greater than sign, and then 18. So then HO is the opposite of greater than, which is less than and equals. Okay, and that's literally how easy it is to set up your hypothesis statements. But look for those keywords. If you see more than, larger than, bigger than, greater than, they might even say the word greater than, that's a sign that you're going to use a greater than sign. If you see smaller, less than, weaker than, okay, those are indications of the less than sign. And if you don't see words that indicate a particular direction, if you just see the word like is, that just equals. When you're doing hypothesis testing, there's no guarantee that what you're doing is actually correct, because there's always error, okay, especially due to sampling, okay? Just because we do these tests, it doesn't mean you're 100% accurate, okay? This isn't something that's going to be on the homework, but something I just wanted to touch upon, okay? At the end of every test that you do with hypothesis testing, you're going to make one of two decisions. You're either going to reject the null hypothesis, so reject the HO, or you're going to fail to reject the HO. And because of the decision you make is based on a sample, there is a possibility of making the wrong decision. And this table can kind of help you determine whether or not you've made a type 1 or a type 2 error. A type 1 error occurs if your null hypothesis, HO, the HO, is rejected when it is in fact true. Okay, so if you reject the null hypothesis and you say, no, the HO is wrong, the HO is wrong, and then you find out afterwards it was actually okay, then that's a type 1 error. Okay, a type 2 error is the opposite. That's when you don't reject the HO when you really should have. The reason why I'm not going to ask you any questions about this on the homework is just because in reality, this is a hard thing to actually determine if you've made a type 1 or a type 2 error. So this is just like a theoretical thing that we talk about in statistics, but it's not something we're going to actually delve into more detail. What is important though, when talking about like type 1 versus type 2 error, is that type 1 error relates to level significance. And this is how much of type 1 error you're comfortable making. So basically, this is how likely you are to falsely reject the null hypothesis. And basically, we want this to be a very small percentage. We really don't want to make a mistake when we reject the null hypothesis, which usually is our goal in research. We denote this as alpha, which is the Greek letter for A. And by setting your level of significance at a small value, you are saying that you want the probability of rejecting the true null hypothesis, or HO, to be small. In statistics, we commonly use either 0.1, 0.05, or 0.01. In class, I'll actually be using 0.05 a lot. That's a very common alpha level in hypothesis testing. 0.01 is more so used in the sciences, and especially in biomedical research. 0.1 is probably okay in social science. But think about it this way, like 0.1 basically says, okay, there's a 10% chance that you reject the null hypothesis when you should not have. Okay, there's a 10% chance the null hypothesis was actually true. Okay, there's a 5% chance in this case that the null hypothesis is actually true. There's a 1% chance that the null hypothesis is actually true. We want that to be small because in many cases we don't want to prove our null hypothesis. Sometimes which we won't talk about in this course so much, but sometimes we use type 2 error to determine what's called power, and basically that's the probability of actually being able to reject the null hypothesis. After you state your null and alternative hypothesis, and then you determine your alpha level, then you should take a random sample from a population and then gather your sample statistics. That's basically your sample mean or your sample proportion. The statistic that is compared with that parameter is called the test statistic. So in this case, for means, we use the sample mean to basically gather an estimate about mu. We would use a sample proportion, or p hat, to better understand what the true proportion is, or p. Okay, and then when we're doing actual hypothesis testing, we'll use the t-test for means, and we'll use the z-test for proportions. And I'm going to start a new video and pick up where p-value is.